Hello, everyone. I'm here, as Nexi said, to talk about ops at NPM. So I'm also, as Nexi said, no surprise here, Maciej Malecki, and I talk to servers there, which is why I'm here to talk to you about ops at NPM. Sorry if I'm a little jittery. I had some coffee, but I haven't had any food yet, so this might just go too fast. All right, so let's start with a bit of history first. So in 2013, this new NPM thing wasn't really all that popular yet. So that was the entire architecture of the registry in year 2013. A single poor CouchDB handling all the read, all the write, all the website requests, handling all the view generation and stuff like that. And let me tell you, that was very fine. In 2013, there wasn't any real load yet. So Monolith was fine. Monolith was just fine. I see the reason why NPM registry was first written as a monolith. It's easy to write. It's easy to deploy. You just stick your views into CouchDB, which can run on a shared hosting, and just forget about it. Except that sometimes you can't really forget about that. Because monoliths are actually hard once you really think about it. Monoliths are hard to maintain because you have this one huge code base that has the potential to break everything you do when you deploy it. And that's a kind of scary thought. They are also hard to make redundant. And if you don't make things redundant, you can't really make them available unless you live on some other world where computers don't break. So yeah, this one poor CouchDB was handling everything. And as I said, that was fine. 2013 is right about here. So we had, as we can see here, 30,000 packages and some, I would say, 75,000 downloads in a month. That's not too bad, actually. But when this graph grew, about here was when CouchDB stopped making sense. And to understand why, you need to know one thing about CouchDB and how we wrote back then. So all of the documents at NPM are, of course, stored in CouchDB. They used to have attachments there, which were the actual packages. So the main problem with that was that with each read request for a package, the attachment was actually encoded in base 64 in the single .couch file, which is the entire database. So for a package read, CouchDB needed to base 64 unencode the tarball and just send it out to the user, which was, of course, CPU bound at that amount of downloads. And a single CouchDB stopped scoping. Like, we had way less than 98% uptime, which is kind of deplorable, right, for a thing people rely on. We didn't know that we were down. People were telling us on Twitter, hey, your stuff is on fire. Maybe come look at it, because I can't really work right now. So that was fun. But we actually managed to dig ourselves out of the hole. Right now, our weekly registry uptime is 99.96. So funny story, when I was making this slide yesterday, I was looking up the exact statistics. And at the previous talk I gave under a very similar title, I bragged about having 100% uptime, which actually was not true. It turned out that our monitoring only checked that every 30 minutes. So not really 100% uptime, but we are pretty close. We're working on this. We don't really know what's causing the 4 to not be there, but we will keep working on this. So how did we really dig ourselves out of the hole? Well, turns out that breaking the monolith is what we did and what we should have done. So we did it boringly, because who here likes being waken up at 3 a.m. For a pager duty alert? Oh, one person. There, two people. There we go. All right. You folks must drink lots of coffee then. I don't like having fires at 3 a.m. I think fires are not good for your health. So this is actually the founding rule that CJ, our current CTO, came up with. I want our software to be boring. I want it to work, and I don't want to have to look at it every now and then. And that pretty much set our entire kind of approach to doing ops and software development at NPM. So if you were expecting like super hot and new technology to come up with this talk, like if you expected me to say, yeah, we use this database that came out 2 weeks ago, that's not going to happen because those things tend to catch on fire. The newest thing here in this talk is probably etcd and InfluxDB, which are both kind of proven in production. And that's the software we try to go to. So the first thing we did, as I mentioned, we did not know if we were down. The users telling you that you're down on Twitter is both bad luck and, I mean, come on, what the fuck? So we started monitoring heavily. Everything that's caused problems in the past is right now monitored. We have, right now, every 30 seconds, we have 781 checks running on all of our 105, I think, production servers or so, something like that. So we even monitor for things that might seem silly at first. So for example, we monitor if the offset of the clock on all the servers matches. The reason we do this is that on the website some time ago, we had packages that were released like 2 minutes in the future, so kind of a time machine that shouldn't have happened. But if someone comes up with a time machine concept, feel free to credit me for that. So yeah, 781 checks. That's fun. And then obviously, once you put monitoring on something, it just doesn't break anymore. It's like, doesn't want to be watched breaking, I don't know, computers. Yeah, as I said, we broke up the monolith. So what we started off with was just kind of taking all the requests that were going to CouchDB and proxying them through Node. So at first, it was a really simple proxy. All it had to do was proxy stuff. But it gave us kind of a hook into what we can do with the data, and it let us kind of redirect the traffic as we wish. So I wish I could show you the architecture diagram. However, my browser won't really let me resize all that much. It won't even let me resize at all. That's fun. How does on computers? Oh yeah, there we go. Oh no, that's actually. Yeah, OK, so that's how far my browser goes here. But the graph is pretty huge. All the services are kind of hidden there, and I can't really seem to scroll it. So, oh no, there's a scroll bar here. Yeah, there we go. So yeah, that's fun to maintain, but also it's way easier to maintain than a single monolith CouchDB ever would be. Oh yeah, there we go. However, with us breaking the monolith, CouchDB still drives everything. So how we use CouchDB at NPM is it kind of started out as everything, and right now it's still kind of everything, except only for JSON. So we use the changes feed. So the changes feed is a CouchDB feature that lets you listen to any changes happening on the database. It's really awesome. I think CouchDB, that's the reason CouchDB makes my most favorite database for stuff, just because you get to watch all the things happening in there. So NPM at present runs probably something like 10 followers. So every time you go to for example, our website, the data, like READMEs and dependencies and downloads, they're all populated by a follower that just runs in the background and updates the caches the website uses. We really like this model. It lets us be kind of eventually consistent where we want and don't have to be immediately consistent. So yeah, followers drive everything at NPM. We cache wherever we can. I know it's one of the biggest computer science problems, but I think we actually got that right. So back to the boring part. So in the best case, if you npm install a package, your request never ever hits our servers. That's what we want to do. We just don't want to answer to your requests. We have a CDN that does it for us. They're called Fastly. They're really nice, really responsive. And yeah, we just hand off all the caching to them. So right now, our cache hit rates is like 98%. 98% or so. So 98% of requests never actually make it onto our server, which is nice. And if they do, it's most likely just one server along the way, which forwards requests to an Nginx server. As I said, boring stuff, Nginx, who uses that? So we manage our deployment with Ansible. Ansible is this cool ops tooling that's actually also boring. So what do? You just tell Ansible what state you want your server to be. So for example, here we create the file system hierarchy that we use at NPM. So just some common directories which we put stuff in. And all we need to do is tell Ansible that we want this directory to exist, and it's going to make it happen. So it's nice. We have almost everything scripted like that. So if you wanted to, for example, spin up a new host or provision a new host to run the dub, here's what you do. You just run the Ansible playbook, and it happens. Yeah. Next thing, we manage our infrastructure with Terraform. This was actually my project, so it's like my little baby. And we wrote like a bunch of tooling around Terraform, because Terraform language right now is... OK, so maybe back to what Terraform actually is. So Terraform is kind of like Ansible, except for infrastructure. I'm going to show you the production file we have for Terraform. Actually, staging, maybe. Oh, that doesn't work too well. Right, so all we have to do to have Terraform create an instance for us is just tell it that we want docs-1west-staging to exist with those parameters. And then when we run Terraform apply, it will make it happen. So as you can see, lots of our tooling just kind of makes it happen. And I'm really happy with that. Also, if you want to do this, do the definition automatically, that's part of the tooling we wrote. So we have a tool that just outputs the standard Terraform definition to the instances file. So in the best case, we're able to spin up a server with just 2 commands, which is pretty nice. Oh, and if I were to, for example, say, destroy the entire staging right now, I'm pretty sure my manager wouldn't be happy with that. But if I were to do that, it would take about 10 minutes to rebuild that. So we automate really heavily on the tasks that tend to happen often and that tend to happen in stress. We've had some stressful server replacements back in the day, and it's always stressful when something goes down. But we are trying to make it less stressful in that we let the machines handle more stuff, because humans fail. We forget things. We forget security groups. We forget what our availability zones are. So, yeah. We don't really have any pet servers anymore. There are 2 servers that are just one-off. That are just backups for our monitoring system, business metrics monitoring system. We automate literally everything. It's not even like a repetitive task. Like if I set up a server that's only going to be set up once, I'm still going to write down the configuration and all the Ansible stuff, because AWS tends to kill servers once in a while. And all the servers will need to be rebuilt eventually. So it is a repeating task when you think about it. That's the other thing we are pretty proud about. We can survive an outage of one DC, of one AWS data center, and still be able to serve traffic. This is because Fastly handles failover for us. So if Fastly notices that all the servers in US West 2 are down, it will just redirect traffic to US East 1, and we're still able to serve packages to people, which is what we do, which is pretty important. Right. And funnier thing, we can even survive an Amazon outage, like an actual truck hitting the data center and not even notice. This is really because we don't really depend on AWS all that much. All we do is run instances. So we don't even use S3 for package serving purposes or anything like that. We just rolled our own here. But that also means that if we want to, if AWS goes bankrupt, that will be the day. We can just migrate to DigitalOcean or GC and be OK, because no special services from Amazon. And the truck hitting the data center wasn't actually a joke. We survived that and still served traffic. Well, Netflix went down and such. So we started graphing our metrics. And the day we stood up the dashboard, I just sat down and started making graphs. And I had no clue how little I knew of our infrastructure and how it actually works. Being able to graph things, at least like the request rate to various services, tells you a lot about our system. So, for example, recently we were looking at a really curious bug where Registry Relational would just stop answering. Registry Relational is the part that answers all the website requests about dependents and such. So at one point, Registry Relational started crashing and not answering every half an hour. So that's one of those bugs, right, where you just spend 2 days sitting down trying to figure out. But our colleague Ben looked at the graphs and noticed the 30-minute part right away because, I mean, you can see all the spikes and such. This is not the actual graph, by the way. And he was able to fix the bug by just rotating around parts in other parts of our system, which is really neat. So we have something like 20 dashboards in our Grafana setup, I think. So now to the actual deployment part. So on top of Terraform, on top of Ansible, sit all of our tools. So we wrote quite a few really simple Unixy tools for deploying our stuff. And thanks to that, deployment is as simple as git push origin, master, deploy production, deploy staging. We also employ something that's called canary environment, which is like the canary in the gold mine. And that just gets like small part of production traffic. And if that dies, we obviously don't go further. So this is how we do our application configuration. And we store all the configuration in etcd. All of those. This here is a key in etcd. All of those are. And what we do when we deploy things, we take all the keys in etcd, we template this file, we output a upstart configuration file, and this actually has a nice, really nice side effect. If etcd goes down, yes, we can do deployments, but we do not do the thing where if you restart your application, the configuration is refetched, because that's just a recipe for disaster. We want to make all the actions that can break our system very explicit, which is why refetching configuration is also explicit, either by just telling the host to refetch the configuration manually, or just deploying to the host. So yeah, we try really hard for everyone to be able to do ops. I mean, we are mostly in the US, so the time zones there kind of vary, and so we would like to have 24-hour coverage of our ops instance. So we try to get everyone to be able to do that, to do the very basic tasks that are common on our infrastructure. So everyone knows how to roll a server. Everyone knows how to restart something. Everyone knows how to create an instance. And that's actually really good. I find that really empowering to just give people the tools they need to do their own thing. And I mean, if you document it well, it's less work for you later on. So, and about documentation, we really try to keep our ops docs updated. It's kind of hard when you roll as fast as we do. I think we rewrote our deployment stack like 2 times already. But we try to make the docs at least correct. That's the most important part for me. If the docs aren't correct, they better not be there because they are actively misleading. We also have this one document that's pretty much the most important document in our repo, which is when Nagios alerts. It describes all the situations that can happen. And it also includes all the steps you can take to fix a situation and diagnose a problem. So handling outages is actually pretty damn easy if it's a common one. If not, it's not a common one, then tough shit. Slack is becoming a part of our ops workflow. It's been for a while. It's been in that we have 2 Slack channels. We have ops log, which is where you put all the things you do on servers, and we're pretty strict about that. So if you roll a server, if you restart a server, deploy new configuration, you say something. So if you see something, say something. There's also deploys, which is just the log of all the deploys going on our platform. It's a pretty noisy channel, so nobody really sits in there. But if we want to know what's going on right now, if you want to watch the servers reporting their status, their deployment status, that's where we go. We have bots. We have tons of bots on Slack. One of the bots is Hermione. So she's the ops wizard, and she can do things like list the names of the services we deploy. She can list the commit hashes, and she can tell us if a server is out of date. Ideally, we want to automate that, but right now it's just a query. Did you ask Hermione? I would show you the actual query, but I broke Hermione yesterday, so I really can't. Oh, there's one slide missing here. Anyway. So in the close future, what do we want to do in the close future at NPM? Well, our first thing that's been going on for a while now that we haven't really had the time to kind of implement is Numbot, our own open source monitoring system. It's really neat. It's stream-based. It has its own channels in Slack as well, where it tells us what it thinks it's broken. But right now, Numbot is broken, so it thinks everything is broken, and we can't really use that. It will run alongside Nagios because, again, boring is fun. Nagios is, what, like 15 years old? I guess it might as well be older than me. So we trust Nagios, and we'll continue to do so, but we were on the lookout for a monitoring system that just lets us do more advanced processing. So for example, maybe we will be able to detect that a AWS machine is about to go away because its I/O metrics are way up. Next thing we're planning to do is service registry. So coming back to the configuration side, you'll notice a bunch of underscore URL keys here. Those are, of course, URLs to our internal services. But that kind of sucks because you have to update it every time a server goes away. And I mean, who wants to do that, right? That's just more work. Why would you want more work? So we are working on making a service registry. We actually took the first step already. We clustered our etcd. We have some proof of concept code. And we just really want to be able to have services find themselves. So for example, I would like our dub to be able to go, hey, I need to find the CouchDB. Where's the CouchDB? And just get that reply from etcd. That will be really neat and really make our jobs easier. Next thing, world domination. But seriously, world domination. Right now we're running in US, EU, and that's it, actually. So Australia is our definitely next stop. I guess Dominic Tarr can tell you how long NPM installs take in New Zealand. So Australia is kind of a priority here. Yeah. But overall, system working? Seems to be. OK, fine. Yeah, so we've come a long way, but now we are here with 99.96% uptime. It was a long way. It was a fun way, but that's pretty much it. Thank you very much.